In this video, we're going to begin to solve equations that contain trig expressions in them. And this video is going to contain all examples where your trig equations have normal periods. So let's review quickly what a normal period is. Remember that 2 pi is the period for sine, cosine, cosecant, and secant. And pi is the period for tangent and cotangent. And if you'll remember, whenever we were graphing these trig functions, we talked about how, like when you have a trig expression, that there's a b value that sits in front of your x, or your theta, whatever that is, and that b value determines your period because you do 2 pi divided by b for sine or cosine, or if it's a tangent problem, you do pi divided by b. So all of the problems that we're going to do today, if you'll notice where your x or where your theta is in the equation, there's no value in front of the x or the theta in any of these examples. So this means that these problems all have that normal period of pi or 2 pi, depending on which one it is. So when we solve the equations, we want to give all of the answers on the interval 0 to 2 pi. So basically we want all the answers in the unit circle. Now remember that 0 and 2 pi are the same angle, so you don't want to give both of those as an answer. You're going to give one or the other based on where your bracket is. Here we have a bracket on 0, so that means if I got 0 or 2 pi as an answer, I'm going to give 0, not 2 pi, because 2 pi has a parenthesis, which means we're going to uninclude that. Okay, so we want all the answers that apply from the unit circle. So this lesson obviously requires you to know your unit circle very well. Okay, so to look at number 1, we want to solve 2 cosine theta equals 1. In other words, we want to find the angle that would go right here that would make this equation true. So when you're solving a trig equation, what you want to do first is isolate the trig part. So I want to get the cosine of theta by itself, which means I would have to get rid of this 2 out front. So I would divide both sides by 2, and those are going to cancel. So I'll have cosine theta equals 1/2. All right, you can't separate trig from its angle without doing an inverse. Remember, this expression means what angle has a cosine of 1/2. Okay, so another way to write that is theta equals the cosine inverse of 1/2. So what angles in the unit circle have a cosine value that's 1/2? Okay, and this is where you just have to know your unit circle. If your cosine is positive, like this one is, 1/2, that means it has to be in quadrants 1 and 4, because cosine is your x value. Okay, and so it happens to be at pi thirds and 5 pi thirds. And we're going to give our answers in radians unless you're told specifically to give it in degrees. Okay, number 2, 2 cosine theta minus 3 equals -5. So this is the part that we want to isolate. All right, so the first thing that we would need to do is get rid of this -3 by adding 3 to both sides. So we're going to have 2 cosine theta equals -2. All right, we're still working on getting this part isolated. So now we would divide both sides by 2. So we would have cosine of theta equals -1. In other words, where in the unit circle is our cosine value a -1 at? Remember, another way to write this is theta equals the cosine inverse, or the arc cosine of -1. Okay, remember that cosine is your x value, and there's only one place in the unit circle that has an x value of -1, and that's out to the left, which is pi. Number 3, we have 2 sine x plus 1 equals 0. Sine x is the part that we want to isolate. So we would start by subtracting 1 from each side. So we would have 2 sine x equals -1. Still trying to isolate this, so now we would divide by this 2 out front. So sine of x equals -1/2. Okay, so where in the unit circle is the sign, first of all, negative at? Sine is your y value, and y values are always negative in quadrants 3 and 4. So you know you're in the bottom half of the unit circle. And where is the sine negative 1/2? Okay, that occurs at 7 pi 6 and 11 pi 6. Number 4, 2 sine squared x minus 1 equals 0. Okay, so right now we're going to have to get rid of the square eventually, but right now we're going to isolate that and try to get rid of the 2 and the negative 1. So the negative 1 would come first by adding 1 to both sides. So we'll have 2 sine squared x equals 1. Okay, now we would divide both sides by 2. So this is sine squared x equals 1/2. And now we have to get rid of the square. Okay, so to do that, we square root both sides. And notice what I'm doing over here. When you square root a fraction, you're just square rooting the top and the bottom separately. Okay, so we have the sine of x equals positive negative, because you always put a plus minus when you square root. The square root of 1 is 1, and the square root of 2 is square root 2, because it doesn't have a square root. Now what we want to do is rationalize this out. We don't like having a square root in the denominator. So we're going to multiply top and bottom by square root 2. So what I really want is, where is the sign positive, negative, square root 2 over 2? Once that's rationalized, remember the bottom just becomes a 2. And if you remember, all of your 45-degree reference angles have sines and cosines that are square root 2 over 2. So because I want positive and negative, I'm going to need all 4 quadrants. So all of my 45-degree angles, which would be pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. So it's very important to remember that plus minus, because that's the difference in having 2 answers and having 4 answers like you should have. All right, for number 5, we have negative 3 times the cosecant of theta equals 6. Okay, so we want to isolate this cosecant right here by dividing both sides by negative 3. So we're going to have cosecant of theta equals negative 2. I don't necessarily expect you to have your cosecants memorized. I expect you to have your sines and cosines memorized. So remember that cosecant is just the reciprocal of sine. So I can change this side to sine if I do the reciprocal of this side. So the reciprocal of negative 2 is negative 1/2. You're just going to flip that upside down. Okay, so what I really want to know is, where in the unit circle is the sign negative 1/2? And if you'll notice, we already did that up here in number 3. The sign's negative 1/2 at 7 pi 6 and 11 pi 6. Okay, number 6, we have 3 tangent squared x equals 1. All right, I want to get rid of this 3, so I'm going to divide both sides by 3. So we have the tangent squared x equals 1/3. Now I need to get rid of the square, so I'm going to square root both sides. Remember, it's square root in numerator and denominator. So the tangent of x equals the positive negative. Square root of 1 is just 1, and 3 doesn't have 1, so that's square root 3 there. And then we're going to rationalize that out. Multiply the top and the bottom by square root 3. So really, this is plus minus square root 3 on the top and 3 on the bottom. Okay, remember that tangent is also sine over cosine. Again, I don't expect you to have all your tangents memorized, but you should know that that tangent is sine over cosine. So if you go back up to this step right here, in order to have a 1 on top and a square root 3 on the bottom, you're looking for an ordered pair where the sine value, or the y value, was 1/2, and the cosine value was square root 3 over 2. Because if you did sine divided by cosine, your 2's would cancel and you would get 1 over square root 3, which rationalizes to this. So you're looking for places in your unit circle that have this as an ordered pair. But because you want positive and negative, you want that angle in all four quadrants. So those angles are pi sixth, 5 pi sixth, 7 pi sixth, and 11 pi sixth. And remember, with any of these problems, you can check your answers by plugging them back in. Just keep in mind that since we're finding radian answers, we would need to put our calculator in radian mode. For example, if I wanted to check number 3 right here, I could make sure that my calculator is in radian mode. And then I would type in 2 sine 7 pi over 6, close my parentheses and hit +1 and see if I really get 0, and I do. So I know that that's a correct answer, and you can do that with 11 pi 6 as well. Some other ones are going to be a little harder to check because of the squares. Whenever you check something like this that has a square in it, for example, I'll check pi fourths, you have to actually type it as 2, let's see, where can I write this? 2 sine, put your pi fourths in there, like that, and then a square around that entire thing, okay, for it to go in correctly. So if I was checking this one, it would be 2 parentheses sine of pi fourths, close that, sorry, let me put my 4 in, close that parenthesis, close the whole thing and square it, and then -1 and see if I get 0. And I do. Okay, so when you're checking the ones that have squares, even though the square's written before the x or before the theta, it actually needs to be on the outside with a parenthesis around that whole trig function there to get the right answer. So you can check these, just make sure your calculator's set to radian mode and that you're typing in everything correctly.